Hello everyone, welcome back to my channel Code Mind. I am Alpna and I am here to discuss the concept of the recursion part 2. I already made the part 1 in which I discussed about some basic concepts of functions and recursion. So in this part we will deal with some of the very important examples of recursion. Today, I need a little bit more attention of yours because recursion is one of the difficult topic, as you all know, but very important topic in all campus drive, for technical as well as for coding. Recursion is little bit confusing topic, but if you pay attention, then you will definitely get the topic. So today, be attentive, little bit be attentive. So before going to start, please hit the subscribe button and bell icon so that I will get encouraged to make more videos. Let's start with our topic. So examples on recursion. So first our example is what will be the output of the following code. So given is here void main int I is equals to 5. I is a variable of integer type in which we assigned a value to be 5. So printf %d fun of I. Here we are calling the function. So when we are calling the function, directly it will search for the same. So fun, same function name is there. I is passed here. It is cached in X. And this function is returning something which is of integer type. Now it will come to here. If x is less than equals to 1. So what is passed? I is equals to 5. So it will check 5 is less than equals to 1. It is false. Condition is false. Then it will go for the else one. So we will return x plus fun of x minus 1. Again the function is called here. For how it is calling? X plus fun of x minus 1 means 5 plus fun of 5 minus 1, that is 4. So see here, this is a recursive tree. You will better understand from this graph. So first of all, you call this from fun of I, that is fun of 5. So fun of 5 is called first of all. After that fun of 5, we will come here and we will check this one. 5 is less than equals to 1? No. After that we will else. If this condition is not true, we will come to else part. Return x plus fun of x minus 1. So here 5 plus fun of x minus 1, 5 minus 1, that is fun of 4. This will be returned. So after this, again the function call will be there. Again x is equals to 4. Now again it will check that 4 is less than equals to 1. Condition is false. It will jump to else statement. Again that is return x plus fun of x minus 1. That is 4 plus 4 minus 1. That is fun of 3. Again this fun of 3 will again be called to be here. Again it will check that 3 is less than equals to 1. The condition is false. Again else part. Fun of 3 plus 3 minus 1, that is 2. Fun of 2 will be called. Again fun of 2. Again the function will be called. That is 2 is less than equals to 1. Condition is still false. Again it will go to else part and then return x. X is what? It is 2 plus 2 minus 1, that is 1. So 2 and fun of 1. After this, again it will go with fun of 1. So 1 is less than equals to 1. Condition is satisfied. When condition satisfied, it will return 1. So this whole value is returned with 1. So when it is returned with 1, then this 1 is added with this. This whole will be added. 2 plus 1, that is 3, will be passed to here. This whole is because x plus fun of x minus 1. So this returned to 1. 1 plus 2, that is 3. Now 3 is added with 3 is passed to here. 3 is passed to be here. Now 3 plus 3 is equals to 6. Now 6 is passed here. Now 6 plus 4 is equals to 10. So 10 will be passed to here. This value is 10. After this 10, 10 plus 5 is equals to 15. So fun of 5 value is equals to 15. So our output is 15. Once again I will say that this is a recursive tree. So x plus fun of x minus 1 means fun of 5 will call to be 5 plus fun of 4. Fun of 4 will call to 4 plus fun of 3. Fun of 3 will call to 3 plus fun of 2. Fun of 2 will call 2 plus fun of 1. So why fun of 1 is not calling 1 plus fun of 0? Because the condition is satisfied. X is equals to 1. When x is equals to 1 less than or equals to 1, then it will return the 1. So this is called the base condition to end the recursive. If it is not there, then it will go to the iterative loop. So base condition is very important to end the recursion. So after this, we will return it here 1. 1 plus 2, 1 will be added with 2, so 3. 3 plus 3 is 6. 6 plus 4 is 10. Now this is 10 plus 5 equals to 15. So 15 is added here. So the output is 15. Okay, next question. What will be the output of the following code? So void main int I, variable I is defined of integer data type. There is a for loop here. Whenever it is a for loop, it will see I is equals to 3. There will be three paths. One is initialization, condition and increment or decrement. So I is equals to 3. I is initialized with 3. I is greater than equals to 3. Its condition is true. When condition satisfied, it goes inside the loop. So inside the loop, fun of I is called. I value is 3. So 3 will be called. Fun of 3 means x value is here 3. In first case, x value is 3. So is 3 is equals to 1? No. Condition is false. So else part will be executed. So this will be executed. Now again 3 minus 1 is 2. Now again fun of 2 is. Now again the function is calling with the 2. So now the x value is equals to 2. In the here the x value is equals to 2. After getting this one, we will again have this 2 is equals to 1. No. So return fun of 2 minus 1, that is 1. Now the third time it is this one 1. So all these are happening for I is equals to 3. This for loop will execute for I is equals to 3, 2, 1 and 0. Why it is 0? Because it is I is greater than equals to 0. If it is minus 1, then it will not be greater than or equals to 0. So I will be 3, 2, 1, 0. So this loop will be executed for the 4 times. So for I is equals to 3, we have how many times iteration? We have 1, 2, 3. You will better understand from this. When I is equals to 3, we have called first function f of 3. After f of 3, it will again call to the function 3 minus 1, that is f of 2. After f of 2, it will again call to 2 minus 1, that is 1. So f of 1. So after f of 1, we had seen 1 is equals to 1. So yes, condition satisfied, so it will return 1. So here it will return 1. The same thing is returned to be f of 2 also. Here it is 1 is returned. Now same thing 1 is returned here also, f of 3. So 1. So now the output will be printed as 1. The first output is 1. Now after 3 it will go for the 2. So 2 will be, x will take the 2. So 2 is equals to 1? No. Condition is not satisfied. So else part will be executed. 2 minus 1 is 1. So first it will check for the 2. So first it will check for the 2, x is equals to 2. After that 2 minus 1 is 1. So 1 will be, it will again go to 1. Function is called with f of 1. So it will again go to here. So 1 is equals to 1. Condition satisfied, it will return to 1. So when I is equals to 2, f of 2 will be there and f of 1 will be there. So f of 1 will return 1 and then again it will go to here. So it will return 1. Okay. In the similar way, I is equals to 3 is completed, I equals to 2 is completed, I is equals to 1. When I is equals to 1, it will return 1 because it is satisfying the condition. 1 is equals to 1, x is equals to 1. It satisfies the condition, so it will directly return 1. I is equals to 0. when I is equals to 0, see what it happens. This is very important case when I is equals to 0, because fun of 0 is passed. Just a minute. Fun of 0. Now here the value is 0. So 0 is passed here. X is equals to x contains 0. This 0 is contained in x. Now 0 is equals to 1? No. So it will return fun of 0 minus 1 is minus 1. Again it will call with fun of minus 1. Again it will go with here. Now x value contains, after 0 it will contain minus 1. Again minus 1 is equals to 1? No. Condition is false, so else part will be executed. So again minus 1 is minus 2. It will call with minus 2. Again the function is called with minus 2. X value is minus 2. This time x value is minus 2. So again minus 2 equals to 1? No. So this will iterate infinite up to minus infinity, because there is no condition of 0. That's why it will gets executed infinite number of times. So output is 1, 1, 1, an infinite loop. There is one more questions in this we can get. If it is here, if it is less than or equals to 1, if x is less than equals to 1, if here it is x is equals to less than equals to 1, then it return 1. Then the output will be 1, 1, 1 and 1. Because when fun of 0 will be here, then x value stores to be 0. 0 is less than equals to 1, condition satisfied, then it will return 1. It will not go for the infinite loop. If x is less than equals to 1, then it will not go for the infinite loop and the output will be this one. Okay. Third question. What will be the output of the following code? This question is very tricky and very important. Just be concentrated, be attentive, you will get. Void function init n. So we know that execution start from the main. We will start from here. So main. In the main we have a fun of 4. So this is calling the function f of fun with the 4. So it will search for the function. So it went to here. Now n contains the value of 4. N contains the value of 4. If 4 is greater than equals to 0, is condition is satisfied? Yes, the condition is satisfied. If condition satisfied, it gets into the loop. So fun of n minus 1, that is fun of 4 minus 1, that is fun of 3. Fun of n is called, see here, this is a recursive tree, you will better understand from this. Fun of 4. Fun of 4 is calling what? Fun of n minus 1. Fun of n minus 1, and then it is printing the n value. What is n value? Here the n value is printed. So here fun of 4 is called fun of 4 minus 1, that is fun of 3. 4 is printed here, and again the fun of n minus 1 is called. Means 4 minus 1, that is fun of 3 will be called. Just see it once, you will understand. F of 4 is there. It calls f of 3. It prints 4 and f of 3. F of 4 minus 1, f of 3, f of 3. Then it will print the 4 and then f of 4 minus 1, that is 3. Again this function will be called, means f of 4 minus 1, f of 3. From this again f of 3 will be called. N is equals to 3. N is equals to 3. From this 3, again this 3 will called n minus 1, that is f of 2. Print the 3 and 3 minus 1, that is 2. That is f of 3 will again call f of 2, print 3 and f of 2. We have dealt with this f of 3. We had not dealt with this f of 3. Now we will go with this f of 3. So f of 3 is equals to f of 2, print 3 and f of 2. Similar way for both the one. For this also and for this also. After 3 we will go for the 2. F of 2, f of 1, print 2, f of 1. After f of 1, we will, after f of 2 we will go for the f of 1. Similar here also we will go. I had not made it here, just concentrate on this. The same will go for here also. So f of 2 will call f of 1, it will print 2, and then it will call again f of 1. Again f of 1 will call to f of 0, print 1 and f of 0. So f of 0 will not be executed because n is greater than equals to 0 and must be greater than equals to 0. So we will not do like this f of minus 1 print 0 and f of minus 1 because the condition is not satisfying. That's why we are not going for that. After this one, what will be the output of us? So f of 1 is giving what? 1. F of 0 and 1 and f of 0. So f of 0 will not execute because the condition is not satisfied. So our output will be 1. First of all, our output will be 1. After f of 1, f of 2. So what f of 2 is giving? F of 1 print to f of 1. So what is f of 1? 1. So 1 will be printed here, 2 will be printed, and again 1 will be printed. So f of 2 value is total 1, 2, 1. So f of 2 is your 1, 2, 1. So first f of 1 is printed, that is 1. Then f of 2 will be printed, that is 1, 2, 1. So this is here. After this f of 3 is printed. So f of 3 is f of 1, 2, 1, this one. After that print 3, 3 will be printed, and again f of 2. F of 2 is what? 1, 2, 1. So this is printed 1, 2, 1. This whole is your f of 3. F of 3 is what? 1, 2, 1, 3 and 1, 2, 1. This is f of 3. After this f of 3, this is 4. This will be printed what? This will print 4. This first of all, this will printed, then 4 will be printed. Again the same thing will be printed because this is the mirror image of this one. So in this also 1, 2, 1, 3, 1, 2, 1. So this will get printed. This will be the output. So this is a palindromic number. This is very important question, and this question is asked many times in the exams. So go through that once more. Next question. This will be the last question. What will be the output printed? So execution start from the main. We will start from here. Printf percentage d fun of 200. So whenever we find fun of 200, we will search for the same function. So we find it here. So I value is here 200. I is equals to 200. So function is called with the 200. Now 200 mod 2, is it 200? Yes. But the output is 0 because it is completely divisible. 200 mod 2 is equals to 0. So if 0, so condition is false. This is 0 represents the false. So 0 represents the false. So condition is false, that's why else will be executed. So what it will return? Return fun of I minus 1. So I minus 1 is what? I minus 1 is 199. So again the fun of I minus 1, that is fun of 199 will go. Means I contains the value of 199. So 199 mod 2, is it equals to 0? No, it is not equals to 0. So 1 means it is true. It is true. So 1 means true, 0 means false. So condition is true. So if block will be executed. So what it is? Return I plus plus. So it is what? It is post increment operation. I already made the video of post increment and post decrement and prefix. So go through that video. You will better understand that one. So first I plus plus, what this I plus plus means is, I plus plus is I is equals to I, and after that I is equals to I plus 1. Means first the value will be assigned, then the value will be incremented. Means return the 199 to this one and then increment the value of I. So it is returned here 199 and then the value is incremented to 200. So what will be the output? 199. Okay. Thank you. If you like the video, please hit the like and subscribe button and press the bell icon to get the latest notification from my site. Thank you.